Meet Alex and Sam, identical twins. Same birthday, same face, same terrible taste in socks. But today that's about to change forever. Sam is about to strap into a rocket and blast off into deep space at ridiculous speed, while Alex stays home on Earth, probably re-watching the same 3 shows. When Sam finally gets back, plot twist. The twins are not the same age anymore. This is the twin paradox, one of the most mind-bending puzzles in all of physics, and no, coffee will not help you understand it faster. Here's the puzzle. Einstein's relativity says moving clocks run slower than clocks that sit still. So from Alex's couch, Sam is the one zooming away, so Sam's clock should be the slow one. Makes sense so far. But here's the annoying part. Motion is relative. From Sam's rocket, it looks like Alex and the entire planet Earth are the ones rushing away at high speed. So by that logic, shouldn't Alex's clock be the slow one instead? Both twins can point at the other and say, "Nah, you're the one moving." If they're both right, who actually ages less? That's the paradox, and it's been giving physics students headaches for over a century. To crack this, we need a quick physics refresher. Don't worry, no math test at the end. Picture a clock made from a single photon of light, bouncing between 2 mirrors. Every bounce equals 1 tick. Now put that clock on a spaceship zooming past you. From where you're standing, the light has to travel a longer, diagonal path to make each bounce. And since light always travels at the same speed, no exceptions, a longer path means more time per tick. So to you, the moving clock looks like it's running in slow motion. That's time dilation, and yes, it's been tested, confirmed, and reconfirmed. Physics did not just make this up for fun. Back to our twins. The setup looks perfectly symmetric. Each twin swears the other one is the one moving. But there's one detail that breaks the tie completely. Alex never changes motion, just sits on Earth being, well, Alex. Sam, meanwhile, has to accelerate to leave Earth, slam the brakes and swing around at the far star, then accelerate all over again to come home. That U-turn is the whole ballgame. Only Sam feels the engines shove them around. Only Sam's path through space and time actually bends. That one difference breaks the symmetry, and it's the reason these twins are absolutely not interchangeable. Sorry, Sam. Physicists love drawing this out on a space-time diagram, basically a graph with space on one side and time on the other. Alex's path, called a world line, is just a boring straight vertical line, since Alex never actually goes anywhere. Sam's world line shoots out at an angle, bends sharply at the far star, and angles back home, like a very expensive round trip with one stop. Here's the twist. In this bizarre space-time geometry, the straight line is actually the longest path in time, not the shortest. Sam's zigzag detour adds up to less elapsed time than Alex's boring straight line. Moral of the story, bending your path through space-time costs you time. Rude, but that's relativity for you. There's one more twist, called the relativity of simultaneity. Try saying that 5 times fast. While Sam is cruising at constant speed, Sam's idea of what's happening on Earth right now slowly drifts behind Alex's actual clock. But the instant Sam slams on the brakes to turn around, that sense of now suddenly rockets forward, skipping years on Earth almost instantly. Alex doesn't feel a thing, life goes on, laundry gets done. But from Sam's shifting point of view, Alex's clock just leapt years ahead during that turn. That sudden jump is exactly what makes both twins' math agree in the end. Let's actually run the numbers, because vague hand waving is for amateurs. Say Sam rockets off at 80% of the speed of light, toward a star 4 light years away, then turns around and heads home. From Alex's view on Earth, the whole round trip takes 10 years. But thanks to time dilation, Sam's own body and Sam's own clock only experience about 6 years. When Sam finally steps off that ship, Alex has aged 10 years, Sam has aged 6. Sam basically time-traveled 4 years into Alex's future, and didn't even need a flux capacitor to do it. This isn't just a fun thought experiment cooked up to ruin your afternoon. In 1971, scientists literally flew atomic clocks around the world on commercial airplanes, ordinary tickets, probably terrible legroom, and compared them to identical clocks that stayed on the ground. The flying clocks came back showing a tiny but very real-time difference, matching relativity's prediction almost exactly. Even today, GPS satellites orbit fast enough and far enough from Earth's gravity that their onboard clocks drift out of sync with ours. Engineers correct for this every single day. Skip that correction, and your GPS could be sending you into a lake within hours. So the twin paradox isn't actually a contradiction, it's a clue. It shows that time isn't one universal ticking clock that everyone shares equally. How much time you personally experience depends on the path you take through space and time, and whether that path involves acceleration. The twin who turns around is always the one who ages less. No exceptions, no loopholes, no arguing with the universe about it. Relativity doesn't break here. It just politely asks us to let go of the idea that time flows the same way for everybody. Rude, but fair. Now, you and I are not currently rocketing around at 80% the speed of light. So relax, you're not secretly younger than your coworker. But the universe runs on these rules everywhere, all the time, whether we notice it or not. So next time you look up at the night sky, remember, somewhere out there, time itself is quietly bending. No big deal. Thanks for watching, and if this melted your brain a little, that means it worked. See you in the next one.